Hi, I'm Anju. I'm an environmental scientist and I've just taken some water samples from the river. I'm just finishing off my notes. They include location, date, time, depth of sample taken from the water and weather conditions. What I'm going to be doing is taking these samples back to the lab and checking for phosphates. It's important that these levels are checked regularly. Phosphate elements can aid in plant and animal growth, but can become toxic if too high levels are present. Phosphates can get into the water in various ways, such as natural weathering process of rocks, rotting vegetation, but major man-influenced sources like untreated sewage, runoff from agricultural sites, and detergents in factory outlets is a big factor too. I'll be checking that the level of phosphates in this river is no more than a proportion of 0.1 parts per million, which works out at about 0.1 milligrams per litre. I hope we'll see a better value than that. A good proportion in running water is something like 0.03 parts per million. As you can imagine, these aren't the kinds of sums you can do by the riverside. I'll be heading back to the lab for that. See you later. I'm now testing a small proportion of river water for a reading on phosphates. That's how many parts of the whole are phosphates and how many parts are not. We'll put this 3 ml sample into my analyzer. Whatever it comes back with will be the proportion of phosphates that are present. Okay, the reading was 0.038 milligrams per litre, or if you prefer to think in parts per million, that's 0.038 parts per million. The remainder of the sample makes up another 999,999.962 parts per million. That's a bit higher than I expected, so I'll have to take a look at past readings to see if that can be explained. Here's a graph of the phosphate levels of the river over the last 2 years. The months are along the bottom axis, and the milligrams per litre are on the vertical axis. The levels range from the lowest of about 0.01 to the highs of nearly 0.08. It's now March, so I can compare my readings with that of other years. In March 2007, the reading was 0.04, and in March 2008, the reading was somewhere between 0.03 and 0.04. So my readings do look reasonable. It's really valuable to collect data and display it in graphs like these. An important part of my job is being able to interpret graphs. I can see that phosphate levels are lower in late winter. And this is probably because the water levels are much higher due to heavier rainfall at this time of year. And this can dilute phosphates even further. Here's a different sort of graph, a bar chart, showing phosphate levels taken at a number of different sites along another river. These were all measured on the same day, so the differences are due to the place where the samples were taken rather than the time of year, which was shown in the first graph. Here is a map showing the 5 collection points that we used. We look at the map together with the graphs to make sense of it. The lowest level of 0.003 milligrams per litre was taken at Site 3. This site is well away from all industry and happens to be where clean water wells up from underground. The highest level of 0.05 milligrams per litre is from Site 2, and I can see from the map that this is where the outlet from the sewage works joins the river. Keeping graphs like these and knowing how to read them, things like what the axes represent and how to read off values, is a crucial skill needed for saving the environment. Seriously though, it's not just an environmental scientist that needs these skills. It's a skill worth learning with any job that involves measuring. So go on, give it a go.